Hello, good evening. Now, suppose you're being asked to find out the stereoisomers of two different compounds. We'll see. You're being asked to find out the total number of stereoisomers. Firstly, there may be a confusion whether this carbon is chiral or not. Now, if you consider only the constitutional part or the structural part, that it may seem that both these groups are same. One is hidden IH, and both these groups are same, so it does not seem chiral. But if you consider the configurational wise, then it may be chiral, and it will be chiral. Suppose I am considering because these two can exhibit geometrical isomerism, these two portions can exhibit geometrical isomerism. Suppose this is cis, this is cis, then this carbon is achiral. Suppose this is trans, again achiral. Now suppose this is cis, this is trans, the same as this is cis, this is trans, then carbon becomes chiral. Now once we know this fact, let's see how can we find out the total number of stereoisomers. Now the common mistake the students do is that they actually do that the number of stereoisomers, there is one formula, if the number of stereo centers is n, then the total number of stereoisomers is 2 to the power n. But this cannot be applied here. For here you have to actually draw the structure to do it. That's a common mistake. This is just to give it 8 and so and so, but no, it's not possible. Let's see. So we have cis, trans, and cis-trans. Okay. So if we first consider the chiral one, when this center carbon becomes chiral, that means let's say the trans and cis one. Now this portion is now trans and this portion is now cis. So if we look at this carbon, this hydrogen here, now there is no plane of symmetry, neither there is a center of symmetry, so it's a dissymmetric molecule and it is optically active. So optically active means it can exist at D plus L, so there are two isomers possible. Okay, now let us consider both sides being cis. This is quite simple. Now this carbon is actually not chiral. This carbon is not chiral. Both sides being cis, you can easily see that there is a plane of symmetry present, so obviously the compound is optically inactive. Another possibility is both is trans. Now you can easily see again that this carbon is not chiral, and there is a plane of symmetry present in the compound. So this compound is again optically inactive. So total number of stereoisomers, we have covered all the portion: cis, trans, and trans. So trans and cis with the chiral carbon that is optically active, there are two stereoisomers. Cis not chiral. This molecule is not chiral. This is an achiral molecule. So there is a one stereoisomer. Cis. After all, this is geometrical isomer. They are showing this. They are cis and cis. And here it's again achiral, optically active. So 1. So total number of stereoisomers Total stereoisomers is 4. Total stereoisomers is 4. Now if you take another compound, this is a quite important one. Now here, if we consider that this 2 carbon is obviously these 2 carbons are chiral, these 2 carbons are actually chiral carbon, because for this carbon methyl OH, and this group for this carbon hydrogen OH methyl, and this total group. So this 2 carbon, again this can exhibit geometrical isomerism. Now one thing some may say that okay, these 2 groups are on the same, but again this may be R, this may be S, and so and so. So the common mistake, again the student which they simply find out that the number of stereocenters. What is stereocenter? Stereocenter is a double bond and an atom, which may be anything, carbon, nitrogen, sulfur, whatever, where across which a double geometrical isomerism double bond and atom across which a geometrical isomerism as well as optical isomerism can exist, can occur. That's called stereocenters. So, and they can simply apply the formula 2 to the power n, but it won't be applicable here. You have to consider actually the structure. Now keeping that in mind, if we consider this one first, just a moment. We keep this trans with this alkene portion trans, and we keep making this 2H seized with respect to one another. Now from this diagram it may seem that we have out and be seized. Now let us consider the actual skeleton. It will be become easier for you if you consider the skeleton. After all, you are in class 11 or 12, so you're doing it may be difficult for you. So if I consider this carbon, for this carbon and this carbon, for this carbon and this carbon, the 2 OH are on the same side. So a same side means both are above the plane. Both are above the plane in this case. That means we have like this. This is sp3 carbon. So it can be like this, it can be also like this, it doesn't matter. Here also, if it is if this is above the plane, then this will be also above the plane. This will be on the same side. So if we look at this carbon, look at this compound, there is no plane of symmetry present, neither any center of symmetry present. So this compound becomes optically active, so it can exist at dextro and levo. So there are 2 stereoisomers possible for this particular configuration. Now keeping again the geometrical isomerism across the double bond trans, if we just consider this one, where the 2H, here the 2H are both above the plane. Here one wedge is above the plane, another wedge is below the plane. It will become much easier if you consider the skeleton, actually skeleton diagram. This is trans, and across the double bond it is trans. Here it is, if above the plane, then in this case it will be below the plane. It will be much more easier if you draw this diagram, otherwise it will be quite difficult for you. Now if you look at the structure properly, there is a center of symmetry present. So center of symmetry present means the compound becomes achiral or optically inactive. Okay. Now we have considered the geometric isomerism where both are trans. Now let's see the geometric isomerism where the it will be C's. This is pretty easy. This is one configuration of the C's where this is a C's configuration across the double bond, and both the OH are above the plane. This you don't need to draw the skeleton diagram. From simply this one, both are above the plane, both are C's actually with respect to one another. Here if you look at this this one, these are actually C's with respect to one another, these two OH, and here these two OH are actually trans with here these two OH are actually C's with respect to one another. Here these two OH are trans with respect to one another as shown. Now here both are C's, both are C's, so obviously just by looking at the diagram we see that there is a plane of symmetry present, so the compound become optically inactive. Now if you consider this another C's across the double bond, but making the two OH C's and trans with respect to one another. Now whether this molecule will be chiral or not, that's now it may be difficult from this diagram for you, which just appeared in just in class 11 or in just gone to class 12. So if you draw the actual line diagram here, if one OH, this is above the plane, this is below the plane, so if one OH is on this side, the other OH will be below. So if we look at this particular diagram, now it becomes pretty simple. There is no plane of symmetry present, neither any center of symmetry present. So this compound becomes optically active. This molecule is actually chiral. Optically active means it can exist at the external level. So what is the total number of stereoisomers possible? This is optically active, so there are two stereoisomers possible here. This is optically inactive, so 1. This is again optically inactive, so 1. And this is optically active 2. So the total number of stereoisomers is 2, 1, 3, and 4 and 6. So the total number of stereoisomers of the second compound is actually 6 and not 8, which is the very common mistake the students make. Okay, hope you have understood this properly. Now my name is Gautam Das, and my class is GD chemistry classes. I conduct chemistry classes for competitive exams, JEE Mains, JEE Advanced, and NEET. First of all, if you want to see this type of videos, this type of complicated questions for those competitive exams, you can subscribe my channel. And if you like the video, please press the like button. But better if you join my classes, where we will do the detailed thing, everything. You can do chapter wise, you can do the total class. For online and offline class, you can contact me in this WhatsApp number, which is 98300264778. If you are residing in Kolkata, you can join my offline classes, or as well as online classes. And if you are outside Kolkata, you can obviously join my online classes for the competitive exams. Thank you.